Okay, what am I doing today? Little portable development work. So what I want to do is check on one of these things, what it is that the power draw on these things when they're under control. All right, so let's open up. These guys. And in particular, the draw of the Wi-Fi. And so for that, I brought with me on my trip MDP-X. Which should give me hopefully a decent representation of the power consumption of one of these things. So let's give that a shot. Yeah. Plug this guy in. These. So we've got our negative. Positive. Try not to short this out. Keep our negative and positive away from each other. Negative. Positive. All right, let's move up the shield so that we don't. There. Yeah, I don't want these guys to accidentally touch the alligator clips when they come out. And then let's see if we can power this guy up. The best positioning on this. Need to take advantage of some of this left-right space. Maybe I'll put this over here. Yeah. And then let's get these cables back here. And then power this guy up. Oh, whoops. I need to start the power. There we go. Okay. The way we read this, this is the input to the, anything good to point with? Oh, use this guy here. So this is the input to the regulator, which is coming from just a regular 5-volt USB. That's this silver cable here that goes off screen. This is what I've set the regulator to output. So I want the regulator to output 4 volts with a maximum of 2 amps. And then that's the display unit here. And then we can see from the bottom unit is the actual regulator. So there's a little screw on the regulator too, which will match the first output here, which is the measured actual output. So that's the kind of through approximately 4 volts. about changing between 120 and 150 milliamps at 500, right? A net of somewhere around half a watt. That's kind of idle. Then as I turn this on, you can see that the power draw here goes up to 1 watt. And you see there's some jitter. The graph here, of course, is not an oscilloscope, so I'm not gonna be, as far as I know, I can't freeze it. It gives me a relative idea of how stable this is and at what level the 4 volts is. Right, blue was about the same. Right, the cyan is with the RGB LED is drawing, now it's 2 LEDs turned on, so it draws a little more, nearly 1.5 watts. Yellow's a bit down. Green's 1.2, 1.4, 1.4, 7, pink. Okay, so that's the setup here, and the question is then the power spike during transmission. Let's start with then the controller. Turn on the controller. Thought I turned this off. Not out power, am I? There we go. All right. All right, boot up. Wear OS Android watch. Booting. Okay. There we go. All right, let's launch the controller. What happened there? Come on. Is there gunk in the switch? All right, so now we're connected. The power usage go up. Oh, I didn't notice. Okay, I'm gonna have to try that again. All right, let's quit out of the app. That'll disconnect. No, not really much difference. Launch the app. Initializing scanning, connected. All right, so not much difference in power consumption between connected and not connected. Of course, connected means Bluetooth. Now let's put a color on. Let's go red. Okay, so there is a slight voltage spike whenever I send another command. Hard. You can see it in the scope. It seems to peak at we can see that when I'm pulsing, it's going up and down. Do I have I don't know, this is a fading pulse. What else do I have? Most of these are not. Most of these are fade motions. Triphones mode. Strobe. This is not the same color. I think those spikes are transmissions, but all right, now let's. So it looks like each of these divisions is about 250 milliamps. Zero, 250, 500. But there's an occasional spike to 500 whenever we're transmitting. Okay. Running a lot of CPU. This seems better, fewer drop frames. Okay. I lowered the bit rate a bit. That seems to have straightened out drop frames problem. Yeah, so if the baseline here represents going up and down of the light, let me just, do I have... all fades. So that I just trigger. All right, so transmit. Well, so the good thing about having this display is compared to if I had just you know, one of those regular multimeter like amperage measurement things that I put in line with the circuit, even with something like the whatever, the microcurrent measuring things, is that I wouldn't be able to see those spikes easily. I'd have to like barely catch them when the numbers shift. So with the graph, it's a little bit easier to visually pick it up. I guess there's no resending going on. Otherwise, there'd be periodic spikes. That's something I'm going to have to check. I thought I had implemented, but clearly I did not. Then in theory, let's say I turn these guys off. Then what I want to do is change the master, right? Let me turn this guy on, right, which is battery controlled, and then connect to that, right? I'll turn this guy on. It's going to be the slave. Ooh. Lose connection. That was weird. Okay. Right, so this, it has the same blip when it's receiving a command as when it's the direct master. But that's, I think, because of the retry logic. So every time a stick receives a command, it will also retransmit that command. That was for a pretty long amount of time. So it looks like because of the retransmit, the power usage of each of the sticks is about the same. Whether you are the stick that's connected to the watch or if you are a stick receiving a signal. That answered the question. I was a little bit concerned that maybe the stick connected to the watch would be unusually heavily loaded compared to the rest, but it looks like that doesn't happen because the retransmit behavior makes every single one of these guys use about the same amount of power. more thing here. What's interesting though is that I'm not, right, the fading obviously is the result of sending commands, but I'm just not seeing the consistent spike in voltage that would indicate that I'm transmitting pretty much once every 10th of a second compared to when I'm directly changing the color, because it's constantly sending here. I wonder if is the current draw spike something else? All right, so let's try something else. Let's take the current draw real low. Oh, okay, good, right? The bottom one is this guy here is the reset button. So this just transmits. But I am getting a current spike every time I hit this. Okay, so now if I set the brightness real low, and I do the red pulse, I'm just not seeing those spikes. I wonder why. I mean, looking at the spikes in the meter, they seem to happen once every few seconds, where obviously since the brightness is changing, transmission occurring every 10th of a second. Why is that? Yet, when I hit this, pretty consistently, you can see the spike as a result. And this isn't Bluetooth, right? Because I'm measuring the slave. I'm connected, the watch is connected to the guy back here. And Bluetooth just doesn't burn that much power. We saw that previously. So what? Because what's the duration of that pulse, right? It looks like about half a division. That's 20, 12, 18, 24. So each division is 6 milliseconds. Half a division is then 3 milliseconds. Once every 10th of a second, a 10th of a second is 100 milliseconds. Weird. Why is this? I would have I would have expected the draw to be higher when doing something like this. Makes if I do this, I can see them. Well, maybe it just, that 3 milliseconds is just less draw than it seems. It's fine, no big deal, right? So what did we learn? We learned that when any stick transmits, spikes up to be about 500 milliamps momentarily, right? Given the baseline is like, somewhere in the in the 125-ish range, right? So that's 250, all right, 350 to 400 milliamp spike every time a transmission occurs. I guess that's okay. No big deal, right? I didn't configure that. All right, back to some normal amount of brightness. And if I UO, goes up to 4.2, 4.3 watts, and then slowly comes down. Let's do that again. That much heat. Probably should compare. That's more of a. All right. What? All right. Anything else to check? I don't think so. Yeah, one more thing. Let's power cycle these again. Right, so I am hitting the switch on this guy back here. And since the switch doesn't have retransmission behavior, it just the push button transmits. I'm not seeing a voltage spike on the receiving side. And then if I press the one that's under measurement, yeah, since now this guy is the transmitter, when I hit the button here, I see the spike when I change colors. So if I'm not using the watch, transmitting guy uses slightly more power than the rest. But since I can't hit the button like once every tenth of a second like I can for fades, it doesn't make much of a difference. So what did I learn? I guess the main reason why I wanted to try this is to see whether or not the timeline display on the MDP-X is useful when measuring these to try to measure these transient spikes when I'm hitting the transmit. And the answer is like kind of. It's like either there's something different about the power consumption when you're repeatedly using the modem that genuinely means that this spike occurs only. That doesn't make any sense, right? So if I'm only transmitting occasionally, the transient spike is noticeable, but if I'm transmitting every 10th of the second, you can't see it. So I've learned that I can measure that transient spike due to the Wi-Fi transmission, and it's specific to Wi-Fi, not to Bluetooth. But not sure then why when I'm doing a fade where the watch is sending every 10th of a second, the transients don't show up, or they don't show up with much frequency. Yeah, they get averaged out more easily. You only see them once every 2 or 3 seconds, even though there's got to be a transmission every 10th of a second. So that's mysterious. Don't quite understand. But the gold standard is to use a real oscilloscope, right? Use one of those current in-circuit current measurement things and connect it to the oscilloscope so that I can capture on the trigger when there's a transient. I can capture it, and then we can see what we see. And of course, I don't have the oscilloscope here. I'm in a hotel room in Madrid, so this, I think, is all that's happening today. Yep, that's all I need to measure.